Our Tennessee State Standard today is to solve linear equations with rational number of coefficients, including equations whose solutions require expanding expressions using the distributive property and collecting like terms. And we've been on this for a while, and we will stay on this standard for quite some time, probably a couple to 3 weeks. All right, your lesson objective, which you need to write down at the top of your notes, is to combine like terms to solve equations. All right, when you come back to class, we will have an oil and water demonstration. I want you to be thinking about what that looks like and what it could possibly have to do with math. And another problem I want you to be thinking about, Amelia saved nickels, dimes, and quarters in a jar. When the jar was full, she counted the money. She had as many quarters as dimes, but twice as many nickels as dimes. If the jar had 844 coins, how much money had she saved? So I want you to think about setting up and writing an equation and solving that. All right, so our vocabulary to simplify algebraic expressions, which goes along with combining like terms. Each part of an algebraic expression separated by an addition or subtraction sign is a term, and we've seen this before in a previous lesson. Next we have like terms. Like terms contain the same variables to the same powers. A term without a variable is a constant. We have looked at that before in previous lessons. And then the number with the variable is the coefficient. So take some time, pause the video, and write those down. All right, here we have 3 terms, and if you box in the terms, draw the line in front of the sign, you will see that we have 3 boxes or 3 terms. Negative 4x and x are like terms because they both have the variable x to the first power, which you don't see. So if you don't see the power, then it is to the first power. Some other examples of like terms, 3x squared and negative 7x squared are like terms. 8xy squared and 12xy squared are like terms. But 10x squared z and 22xz squared are not like terms. Because remember, like terms have to have the same variable to the same power. And this x is to the power of 2, this x is to the power of 1. So, and this is z to the first power, z to the second power. So these are not like terms. You have to have the same variable to the same power. All right, so if we wanted to model 2x plus 3 plus x minus 2 equals 13, well, you can see I've already got the 13 up there because I didn't want to drag all those out. But 2x plus 3 plus x minus 2. Now, I did those in order of the way I read them. Most of the time, you would group the like tiles together, just what I'm doing now. So I put my x's together, and I put my 1's together. Now, if we box in our terms, draw the line in front of the sign, you will see we have 4 terms. When we put our...
I need Lily Snowden to the office. Lily Snowden.
Sorry, I'm not starting again. When we put our 2x plus, and if you don't see a number, that's actually 1x because you see 1x there. 2x plus 1x, that's where we get our 3x. And when you do 3 minus 2, that leaves us with 3x. 2x plus 1x is 3x. Plus 3 minus 2 would be plus 1 equals 13. So 3x plus 1 equals 13. And we can go ahead and solve that. take away 1 from this side, take away 1 from this side. I'm going to box in my terms so you can see what I did. I subtracted 1 from each side. That left me with 3x equals 12. And you know, our last step before checking is to divide by the coefficient and conquer. So x equals 4. Let's check this real quick. 2 times 4. So 2 times 4 is 8, plus 3 is 11, plus 4 is 15, minus 2 equals 13. So we are checked. All right, so you're going to be writing these steps down. Step 1, we're going to combine like terms. So I'm going to box in my terms. Draw the line in front of the sign. And as I can see, I have a 4x and a 3x. So 4x plus 3x is 7x plus 2 equals 44. Step 2, we're going to eliminate a variable. Well, we don't have a variable on each side, so we only have one variable. We can't eliminate it. We move on to step 3. Eliminate the constant on the side with the variable. All right, that means we've got to get rid of this 2, so we did the opposite. We subtract 2 from each side. That leaves us with 7x equals 42. Step 4, divide by the coefficient and conquer this equation. So x equals 6. So 4 times 6. 4 times 6 is 24, plus 2 is 26, plus 3 times 6, which is 18. 26 plus 18 equals 44. So our solution is correct. All right, let's box in our terms. Draw the line in front of the sign.
Rebecca Stapleton. Rebecca Stapleton. Please go to town, students.
We put our x's together. 5x minus 3x is 2x. We put our constants together. Negative 8 plus 12 would be positive 4. Box in our terms. The box without the constant or without the variable is your constant plus 4. We undo it by subtracting 4. That gives us 2x equals negative 8. Divide by the coefficient and conquer the equation. X equals negative 4. So that gives me negative 20 minus 8 plus 12 plus 12. So negative 20 minus 8 is negative 28 plus 12. That would be plus 24, would be negative 4. All right, draw the line in front of the sign. And what's a like? Well, I only see one box with an X, so I'm going to put my 2 constant boxes together. 30 minus 22. Oh, nope, that's not an equals. So that will give me 10x plus 30 minus 22 is 8 equals negative 42. Box in my terms again. Get rid of the constant on the same side as the variable, so subtract 8. Negative 50 equals 10x. Divide by the coefficient. X equals negative 5. So 30 minus 50 is negative 20. Minus 22 is negative 42. So it is checked. Some more examples. Draw the line in front of the sign. I have two boxes with X, so I'm going to put them together. 2x minus X will just leave me with 1x. X plus 3 equals 8. Box in your terms. We're going to get rid of that constant, which gives us X equals 5. 2 times 5 is 10, plus 3 is 13, minus 5 equals 8. Draw the line in front of the sign. Do-da, do-da. All right, so we actually have two variable terms. So 7x minus 5x is 2x plus 4 equals 2. Box in your terms. We're going to subtract 4 from each side. That leaves us with 2x equals negative 2. Divide by 2. X equals negative 1. So negative 7 plus 4 is negative 3 plus 5 equals 2. And we are correct. And that's the end of the lesson. Let me remind you, see if I've got this, that you definitely want to think about this problem. See if you can come up with how much money Amelia has. And we'll look at that tomorrow. Have a great day.